Hello students and welcome. So today we are starting with our very first unit for class 12th physics, electric charges and fields. Now I know, this chapter can seem a bit scary, thoda sa intimidating hai, but I promise you we are going to break it down so simply it will not just be easy for your exams, but you'll remember it for life. Chalo, let's make physics our friend. What do you say?
Okay, so here's our plan for today. First, we'll tackle the shocking truth about sweaters. Then, we'll properly meet our hero, the electric charge. After that, we will learn the 3 golden rules, very important. We'll also look at some common exam mistakes to avoid. And finally, we'll put it all together to see the big picture. Simple enough, right? Let's begin. So, first things first, let's talk about that everyday mystery I mentioned. You know that feeling, right? Especially in winter. You take off your sweater and you hear that crackling sound. Crackle, crackle. Sometimes you even see a tiny spark in the dark. Or maybe you get out of a car, you touch the metal door handle, and zap, you get a small shock. So what is going on here? Well, the answer to all this is something you've probably heard of. It's called static electricity. And to really understand what's happening with the static electricity, we need to meet the main hero of our story. So what is this electric charge? Let's think about mass for a moment. You know mass, right? It's a basic fundamental property of matter. It's because of mass that there's a gravitational force. Well, electric charge is exactly like that. It's another fundamental, or you could say intrinsic property of matter. But instead of causing a gravitational force, charge is what causes an electric force between objects. It's just a core property, just like mass. As simple as that. Now, here's where things get a bit more interesting. You see, mass is just, well, mass. But charge comes in 2 types, 2 flavors, if you will. We call them positive and negative. So what does that mean? An object becomes positively charged when it has a shortage, a deficit of electrons, and it's negatively charged when it has an excess, too many electrons. For example, when you rub a glass rod with silk, the glass rod becomes positive. And this brings us to the golden rule of electricity, the #1 rule you absolutely cannot forget. Like charges repel. They push each other away. And unlike or opposite charges, attract. They pull towards each other. Remember that. So, okay, how does this rubbing actually make something charged? Let's break it down, step by step. Imagine you have a glass rod and a silk cloth. To start with, both are electrically neutral, no charge. That's step 1. Now, step 2, you start rubbing them together. What happens? Well, the rubbing gives enough energy for some electrons to literally jump from the glass rod over to the silk cloth. So what's the result? Step 3, the glass rod has now lost electrons, so it becomes positively charged. And the silk cloth has gained those same electrons, so it becomes negatively charged. See, it's not some magic. It's just a simple transfer of electrons. That's all it is. Okay, great. Now that we know what charge is, it's time to learn its 3 basic properties. You can think of them as the 3 golden rules of charge. And believe me, these are super, super important for your exams, so please pay close attention. Right. Rule #1 is the additivity of charge. And it is as simple as it sounds. It just means that the total charge of a system is the algebraic sum of all the individual charges in it. Now, what does algebraic sum mean? It's a very important word here. It simply means you have to consider the signs, the plus and the minus. For example, if you have charges like plus 2q, minus 5q, and plus 3q in a system, you just add them up. So plus 2 minus 5 plus 3, that equals 0. The total charge is 0. Simple addition. Now for our second golden rule, the conservation of charge. This one is a really big deal in physics. It says that for an isolated system, meaning a system that's cut off from everything else, the total charge always remains constant. It stays the same. You cannot create charge from nothing and you cannot destroy it. Think about our glass rod and silk cloth again. Before rubbing, what was the total charge? 0. After rubbing, the rod got some positive charge and the silk got an equal amount of negative charge. So what's the total charge of the system now? Still 0. The charge was just transferred, not created or destroyed. It is conserved.
And here's our third and final golden rule, quantization of charge. Now, the NCERT textbook defines this very precisely. It says, all free charge is an integral multiple of a basic unit of charge denoted by E. Okay, what does that mean in simple words? It means that charge comes in fixed packets. It's not a continuous flow. The smallest possible packet of charge is E, which is the charge of one electron. So any charge you find, Q, will always be a whole number multiple of this basic charge. That's what the formula Q equals N times E means. Here, N has to be an integer, like 1, 2, 3, 100, but it can never be 1.5 or 2.7. You just can't have half a packet of charge.
You know, there's a beautiful analogy to understand this. Think of a dotted line. If you look at it from far away, it seems like one continuous solid line, doesn't it? But when you go up close, you see it's actually made of separate, individual dots. Charge is exactly like this. On our large macroscopic scale, it feels continuous. But if you could zoom in, way down to the microscopic level, you would see that it is always made up of these individual packets, these dots of charge E. Okay, let's make this crystal clear with a very small example. We'll use our formula Q equals NE, or N equals Q divided by E. So let's say a body has a charge, Q, of plus 3.2 into 10 to the power of minus 19 coulombs. We just divide this by E, which is 1.6 into 10 to the power of minus 19. And what do we get? We get N equals plus 2. The fact that N is a positive integer tells us that this body has lost 2 electrons. Now, what if the charge was negative, say minus 4.8 into 10 to the power minus 19 coulombs? We do the same calculation, and we get N equals minus 3. The negative sign here tells us the body has gained 3 electrons. See how it works? It's that simple.
Excellent. You've now learned the 3 golden rules. So now let's talk about the silent killers. These are the common mistakes, the traps that so many students fall into during exams and lose marks. Let's make sure that doesn't happen to you.
Okay, first question. True or false? When you rub a comb on your dry hair, new charge is created. What do you think? True or false? The answer is a big, big false. Please remember this for your exams. Rubbing does not create charge. It only transfers electrons from one body to another. No new charge is made. The total charge of the system, your comb plus your hair, stays the same. So which of our golden rules is this? Yes, it's the law of conservation of charge. All right, ready for the next silent killer? The question is it possible for a body to have a charge of 2.0 into 10 to the power of minus 19 coulombs? Think about it. Think about the golden rules we just learned. And the answer is no, impossible, not possible at all. So why is it impossible? Well, let's check it with our quantization rule. Remember, N equals Q divided by E. If we put in the values, 2.0 into 10 to the power minus 19, divided by 1.6 into 10 to the power of minus 19, what do we get? The calculation gives us 1.25. Now tell me, is 1.25 an integer? Is it a whole number? No, of course not. And since N must be an integer, this amount of charge cannot exist freely. You can't have 1.25 electrons transferred. Fantastic work, everyone. You now have a really solid foundation of the basic properties of charge. So let's quickly summarize everything and then see what's coming next. So what are the most important points to take away for your exams? 1. Electric charge is a basic property of matter, and it can be positive or negative. 2. It is additive, just an algebraic sum. 3. It is conserved. It cannot be created or destroyed. And 4. It is quantized. It always exists in packets where Q equals NE. If you remember these points, you are set. Okay, so we know that a charge exists. We know that it can push or pull other charges. But that brings up a really interesting question. How? How does one charge interact with another charge from a distance without even touching it? How does it know the other charge is there? Well, the answer is it creates an invisible region of influence all around itself, an invisible field. And it is this field that interacts with other charges. We call this an electric field. And that is exactly what we are going to explore in our next explainer. So I will see you